All right, let's look at the homework 5.5, problem number 8. All right, so we want to use integration to find the area of a triangular region having these vertices. All right, so let's do that. All right, so let's draw a picture first. So here is the y-axis. All right, here's the x-axis. All right, and so first point is at 0, 0, so which is at the origin, so right here. All right, maybe I'll use red here, so it's easier to see maybe. All right, so that's the origin. All right, second point is 6, 0, so it's going to be, let's see, 6 to the right, 1, 2, 3, 4, 5, 6, so 6 to the right. And so this is the second point right here. All right, and the third point is 2, 6. All right, so it's going to go up 1, 2, 3, 4, 5, 6, and then 2 to the right. So it's going to be right around here. So here. All right, so we have a 2 right here and a 6 up here. All right, so that's the third point. So we connect them together. So we connect those together like that and like that. And it's already there, so I'm going to just shade it. So this is the region, triangulation, we're talking about. All right. So what I'm going to do is I'm going to actually, you can do it with respect to x or with respect to y. If you integrate with respect to x, you can see that this first region is going to be bounded by this line and the x-axis. And the second region is going to have a different upper bound and the x-axis. So you're going to have to do two integrals. So I'm going to try to do try to integrate with respect to y instead. That way, if you look kind of sideways, so this is going to be the top curve, and then that's going to be the bottom curve. So we can just go all the way through, so from 0 to 6. So let's do that. All right, so first we have to find the equation. So easy one would be, so let's look at this line here. Maybe I should. All right, so this line right here, maybe I'll just put a dotted line here. All right, so this is going through the origin, so we know that the y-intercept is 0, so all we need is a slope. All right, so rise would be 6 and run is 2, so it's going to be 3. So equation of this line is y equals, slope is 3x. All right, so we got the equation there. How about the other line? So here, all right, so this line right here. All right, so we're going to have to do, I guess, find the slope. Slope is going to be, let's see, so m is going to be equal to, all right, so going from here to there, so it's going to be drop, so rise would be -6 over, run is 2 to 4, so 2 to 6, so it's going to be 4. So it's -3/2. All right, that's the slope. And then it's going through 6, 0. So you're going to have y minus, maybe I should write that. So here, all right, the point is x1, y1 is out. You can use either one, but I'm going to use 6, 0. So the equation is y minus y1, which is 0, is equal to, slope is -3/2. Quantity x minus x1 is 6. I'm just using the point slope form. All right, so we have that. Then we can simplify a little bit. So this is going to be y is equal to, then we can just distribute this guy to x. We're going to get the negative 3/2x, right? And if you distribute negative 3 over 2 to negative 6, so it's going to be positive. All right, and 2 and 6 cancel out, we get 3, but you multiply by 3, so it's going to be 9 here. All right, so we have that. All right, so that's those are the equations, but since we're trying to do it with respect to y, so I'm going to have to solve those equations for x. So you start out with y equals 3x, so that's the first line there. So by dividing through by 3, we get 1/3 y is equal to x. All right, so you can rewrite it as x equals 1/3 y. All right, so we got that. And the other one, so you start out with a y minus, y is equal to negative 3/2 x plus 9. All right, so let's solve for x. So first I'm going to get rid of this 9 here. All right, I'm going to subtract 9. So you have a y minus 9 is equal to negative 3/2 x. All right, then we need to get rid of this guy. So you can either divide by negative 3/2, which is equivalent to multiply by negative 2/3. All right, so you're going to get negative 2/3 y. And then a negative, negative, positive. 9 divided by 3 is 3. 3 times 2 is 6. And that's going to be equal to x. All right. So we have x equals negative 2/3 y plus 6. All right. So let's set up the integral. So the area is going to be, all right, so we are going from, y is going from 0 to 6. So we have 0 to 6. All right, so right curve is going to be the second one. So it's negative 2/3 y plus 6. And then you have to subtract. All right, the other one is 1/3 y. So minus 1/3 y. And we do it with respect to y. All right, so let's simplify that. So this is going to be equal to integral from 0 to 6. All right, so if you combine y terms, so negative 2/3, negative 1/3, so it's kind of nice. You get negative y. And then you have plus 6. So we're going to have plus 6 here with respect to y. All right, antiderivative. It's a negative y squared over 2 plus antiderivative 6 is a 6y. And then you're going from 0 to 6. All right, then plug it in. All right, so if you plug in 6, so you have a negative 6 squared would be 36 divided by 2 plus 6 times 6 is 36 minus, if you plug in 0 for y, it's going to be 0 anyway, so you're just going to get that. So that's going to be, so this is going to be 18. So 36 minus 18 is 18 again, right? So this is the area of this triangular region. All right, so let's type it in. All right, so you have 18. All right, let's check the answer. All right, I came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.